Hello students, in the last class I told you about the quadratic equation. I told that what is quadratic equation? General formula is the ax square plus bx plus c equals to 0 where a is not equal to 0. I told you that there are two roots in the quadratic equation. Those depends upon the discriminant value. What is discriminant value? Yesterday I told you that d is equal to b square minus 4ac. On the basis of that, I told you that there are three type of the conditions. First condition is if d is greater than 0, then roots are real and different. If d is equal to 0, roots are real and equal. If d is smaller than 0, then roots are imaginary, means there is no real roots. If there is no real roots, then roots are calculated on the basis of the quadratic formula, or you can say that Sridharacharya formula. Perhaps this is not in your course, but today, yesterday I told you that I gave you example that how will you find the different roots. That was d is greater than 0. But today I will tell you example of if d is equal to 0. You will see if d is equals to 0, comma, roots are real and equal. I am taking example. Suppose I am taking here x square plus 20x plus 100, where a is equals to 1, b is equals to 20, c is equals to 100. Since d is equals to b square minus 4ac, so d is equals to 10 square minus 4 into 1 into 100. So you will see here is the b is the 20, so it is the d is equals to 400 minus 400. So d is equals to 0. You can see if d is equals to 0, then roots are equal. How? You will see that x square plus 10x plus 10x plus 100. We'll make pair x in bracket x plus 10, 10 in bracket x plus 10, means both value will be equal, x plus 10 and x plus 10. So x is equal to minus 10, x is equals to minus 10. What I told you that if d is equals to 0, if d is equals to 0, roots are real and equal. You can see that here when you will take a is equals to 1, b is equals to 20, c is equals to 100. So you will write here b square minus 4ac. It is d is equals to 20 square minus 4 into 1 into 100. So 400 minus 400, d is equal to 0. Means the roots will be equal. How you will see that x is equal to minus 10 and x is equal to minus 10. Means both roots are same, which is the second condition. Third condition I am taking that third condition you will see if d is smaller than 0, then no real roots, but imaginary, imaginary, imaginary roots. You will see here. So suppose I am taking here example x square plus x plus 2. Now here a is equals to 1, b is equals to 1 and c is equals to 2. Since d is equals to b square minus 4ac, so d is equals to 1 square minus 4 into 1 into 2. We'll see d is equals to 1 1 1 and minus 4 to the 8. D is equals to minus 7. You can see here if d is smaller than 0, smaller than 0 means any negative number is the in any negative number is smaller than 0. So d is equal to under root 7. So I told you that Sridharacharya formula, on the basis of this you can find the imaginary roots. What are those? When you will take under root d, it is equals to under root minus 7. Now alpha is equals to minus b plus minus, you will take in the same value under root d total upon 2a. So value alpha and beta separately you can take. Alpha is equals to minus 1 minus under root minus 7 upon 2 1 2. Here is the alpha. Beta is equals to minus b minus under root d upon 2a, means beta is equals to minus 1 minus under root minus 7 upon 2, means here are the two roots. You can see these are called imaginary roots, and on the basis of this you can explain this, the two roots of the quadratic equation. In those, suppose you are taking the two roots, so it is, I am repeating this, that the roots of quadratic equation depend upon the discriminant value, which is represented by d, where d is equals to b square minus 4ac, and if the value of the b square minus 4ac or d is greater than equal to 0, then roots are real, different, equal. But if d is smaller than 0, what there is no real roots, imaginary roots. These are the imaginary roots what I told you. Students, today I want to prove the Sridharacharya formula. Suppose in Sridharacharya formula, you will see in Sridharacharya formula, suppose you are taking ax square, means you have to prove that alpha is equals to minus b plus under root d upon 2a, and beta is equals to minus b minus under root d upon 2a. So here, in the proof I am taking, what is the general formula of the quadratic equation? Ax square plus bx plus c equals to 0. On the basis of that I am starting. How you will see? Suppose ax square plus bx plus c is equals to 0. Now, this is the c is the plus, after equal to it will be negative. It will you will take as ax square plus bx is equals to minus c. But for this it is said that this value is, we always change into the form of a square plus 2ab, or if here is a minus, a square minus 2ab, but here is the plus, here is the plus. So you will see that a square plus 2ab form you will take. So suppose I am dividing this value by a. Now ax square by a plus bx by a is equals to minus c by a. You will cancel this one. Now this is a square plus. You can see that a square plus 2ab. You know that every number is the one is the multiple of every number. So you will write here this like, suppose on the place of this one, we can write here x square plus 2 upon 2 into bx upon a is equals to minus c by a. On the basis of this, you will suppose a square means x square plus 2 into x into b upon 2a. This is the value of the b. When you will take the identity formula, on the basis of that you have to prove that a square plus 2ab means what is the value of b? Value of b is b upon 2a. Now you know that in the equation, if LHS in the RHS, we multiply or we add or subtract by the same number, there is no change found. So by adding b upon 2a whole square both sides, I have add here. Now you will see this one, that here x square plus 2 into x plus b upon 2a plus b upon 2a whole square is equals to minus c upon a plus b upon 2a whole square. Means you will see, now you will see here how you will change this into the quadratic identity formula. A square plus b square plus 2ab. Now you will write here x plus b upon 2a whole square. Here will be minus c upon a plus b square upon 4a square. You will see x plus b upon 2a whole square here, and here we will take the LCM 4a square. Then we will divide this. It will be minus 4ac plus here will be b square. Now I am writing this again, x plus b upon 2a whole square is equals to b square minus 4ac whole square, 4a square. Now you will take here, as we know that if there is not perfect square number, suppose 2 is not perfect square number, and you want to make it a perfect square, then under root 2 is the perfect square of, means under root, every number in under root is perfect square of itself. Suppose I am taking here 2, then you can write here under root 2 into under root 2 is equals to, you can write under root 2 whole square. Same like that, this number is also not perfect square. So after this you will take here that x plus b upon 2a whole square minus under root, you will take, it will be b square minus 4ac upon 2a whole square, because equals to 0. Now because 4 is the perfect square of 2, a square it is given. Now this total value is in the form of a plus a square minus b square. So in one bracket you will take a plus b, another bracket you will take a minus b, and now you will prove this value b is equals to this, like you will see how. In the first bracket I am taking, after this in the first bracket I am taking x plus b upon 2a minus under root b square minus 4ac upon 2a. Second bracket I am taking x plus b upon 2a plus under root b square minus 4ac upon 2a. So you will write here it will be 2a. Now you will, x is equals to minus b plus under root b square minus 4ac upon 2a, and x is equals to minus b minus under root b square minus 4ac upon 2a. This is the value of the first root, and this is the value of the second root. This is the proved. Hence you will write hence proved. Means on the basis of Sirdachar formula we can also calculate the roots, but we always use especially for the only imaginary value. So students, today is the second day of my class, and I have completed introduction of the quadratic equation. In the highlighting you will see that general formula is ax square plus bx plus c equals to 0, but if power is 2, that is called quadratic equation. Some conditions are in which quadratic equation is not possible. Suppose if power is negative, x power minus 2, quadratic equation is not possible. 1 upon x square plus x square, yes, it is possible. But if the power is fractional, quadratic equation is not possible. If power is negative, quadratic equation is not possible. So today only these points, with this point I am stopping this my class, and I hope that you will like this class, and if you have any comment, on the basis of your comment I will also work. Thank you.